How's it going? Welcome to another math edition of Freeburg's Free Advice. We're going to take a look at exponential properties and logarithmic properties and do a couple of examples. So first of all, let's just cover the properties, right? The biggest thing I always like to emphasize is that with the exponential properties, you're not just memorizing stuff. Okay, they always try to force too much memorization inside your head anyways. But actually understand where it comes from. Be able to build it yourself, not just be reliant upon that I memorize this and maybe I'll have a note sheet. But understand why it works. So the first thing I like us to take a look at is the idea that a to the fifth is a times itself 5 times. I think most of us understand that. It's just a times a times a times a times a. Okay? Well, all the other stuff is actually going to get built off of that. And that's how we actually come up with all these other properties. So if we look at something like the multiplication, same base with exponent property, some of us may know that, oh yeah, it's addition. Well, why? So here, this is basically 3b's multiplied together times 4b's multiplied together. Well, if I have 3 of them here multiplied together with 4 of them here, it's like I have 3 plus 4, so I have a total of 7. Okay, that's why it works. Let's take a look at something like our division of same base. I've got 6 on top, c times c times c times c times c times c, 4 of them on the bottom. Well, multiplication and division, I can start canceling those. So I'm going to have 4 less of these 6, right? So the 6 on top less the 4 that cancel off from the bottom gives us this subtraction sign. So we see that we have c squared. Okay, how about the same, or the base with the powers of powers? So powers of powers, this is basically like d squared 5 times. So it's like I have 2d's 5 times, which means I have a total of 2 times 10 of them. That's why this turns into multiplication. So I have d to the 10th. Okay? And then my favorite is the negative exponents. Okay? Why do these even work? Okay, so I know that f to the negative 2 is the same as 1 over f squared. Or I could look at it as 1 over g to the negative third equals g to the third. So it's this idea that I flip-flop my fractions when I do that. Well, why does that even work? So I'm going to give you a quick example. If I had something like 2 to the first, and then 2 to the second, and then 2 to the third, okay? Well, we know that that's 2. We know that that's 4. And what do we see we're doing? We're multiplying by 2 each time, right? So as I multiply, this is going to turn into 8. Well, what if I wanted to move backwards a step, and then backwards a step? Instead of multiplying by 2, we'd be dividing by 2. So as I move back one more step, I see that 2 to the 0 power, or anything to the 0 power, is basically like dividing by itself. So that's why 2 to the 0 power, anything to the 0 power, is 1. So that's nice. Well, what if I keep going backwards? I'm going to divide by 2 again. So 2 to the negative 1 is basically 1 divided by 2. That's what we just saw. And if I divide by 2 again, so 2 to the negative 2, this would be 1/2 divided by 2, which is 1 to the 4th, or 1 over 2 squared. Okay? So that's why these work. And same idea, if I went to the negative 3, I'd see that it's 1 over 8, or 1 over 2 cubed. That's why that works. So I like taking a look at that piece, and why does it even make sense that negative exponents flip-flop this fraction. Okay, so that's why. Let's look over here now at the logarithmic. So on the logarithm side, I think the most important thing to recognize is going from logarithmic form into exponential form. So how do I transfer from one to the other? Well, if I have log base b of a equals x, I can say that b to the x is equal to a. So an example of that would be if I have log base 2 of 8 equals 3. I could say that 2 to the third equals 8. And that's essentially what we're doing. So that's a kind of our key piece here to logarithms. One of our other most important properties is that if I take the log of both sides, it allows me to move this exponent out in front. So log p to the x is the same as x times log p. That allows us to move a variable out front. That's why we like using logs so much, so that's a good thing. Note to self, if you see log without a number, it is a base 10. So log base 10 of 10 equals 1. Again, this fits this conversion idea, right? Because 10 to the first equals 10. That's what we're expecting. Same idea, if you see natural log is log base e. So e to the first equals e. We would assume or expect that log base e, or the natural log of e, is equal to 1. Change of base formula, okay, that's kind of what number 4 is here, is going to be if I've got log base r to the s. Maybe you've got a fancy calculator that can actually do this for you, otherwise most calculators have log or natural log, and so we may need to convert this so we can get a decimal approximation out of our calculator. Well, if we use our conversion piece, right, we can look at converting this. This is going to turn into r to some value equals s. Okay. Well, then we can take the log of both sides. So if I take the log of this, so if we take the log of this and we take the log of this, we'll see that we can actually move the exponent out front. So x times log r is going to be equal to our log s. And then we can divide both sides by log r. And that's how we get into this log s over log r. So it's just using this change to exponential formula and then re-looking at it. So these are equal to each other. Don't have to memorize it, just know how it gets built and rederive it. Okay. These two are nice because if your variable's inside the log, sometimes it's nice to be able to combine them. So if I have logs with the same base and they're adding together, I can combine it as one with multiplication. Okay. Similar idea, if I have two logs with the same base, subtraction, we can combine it together with division. Okay, so these are all really good properties and we're going to use them here. So let's take a look at some practice problems. First one, let's do exponential stuff. So we're going to take a look at this being basically a cube of this whole group, right? This whole thing's going to happen multiple times. So it's like we have r cubed times r to the 5th cubed, 2 cubed, u to the 4th cubed, all over our 4u squared. Okay? So now we have powers of powers that we can simplify. So we've got r cubed times r powers of powers. We said we can multiply because like I have 3 groups of r to the 5th, so this becomes the 15th. 2 cubed is a number, so that's just 8. U to the 4th to the 3rd, like 3 groups of 4. So multiplication, we have 12 of them now. Still over our 4u squared. Now we can look at multiplication of the same base and division of the same base. So let's look at it in pieces here, right? So I've got r's here and I have r's there. Together, I have 3 and 15 of them, so now we have a total of 18 of them. Let's look at our coefficient. So I've got 8, and there's a 4 on bottom, so we can simplify that. 8 divided by 4 is 2. And then with our u's, I've got 12 u's on top, 2 u's on bottom, so they will cancel on top and bottom there. So I'm left with just 10 of them on top. And so there is our final answer. Cool. Okay, so there's a little bit of the exponential. I've used a lot of the properties in there, so hopefully that kind of gets you an idea of how to use all those. Let's look at something like number 2 here. So I have e to the x plus 2. Well, the variable is in my exponent. I got to get that out. We know one of our properties is if I take the log of something, I can move that exponent. Well, in this case, since my base is e, let's use the natural log. So if I were to take the natural log of both sides here, the natural log of e to the x plus 2 equals natural log of 5, because I took it on both sides. And then this allows me to move that out into front here. So we're going to say that we've got x plus 2, that quantity, times the natural log of e equals our natural log of 5. Well, we discussed earlier that natural log of e, because this is a base of e, natural log of e is just 1. So that just disappears. So now we can finish up by subtracting 2 from both sides. We'll see that our x is going to equal natural log of 5 minus 2. And there's our final answer. Okay? This last one's actually going to be super complicated. It might not fit on one side here, but I'm going to try my best. We're going to take a lot of those log properties and bring them all together now. Okay? Well, I have two different logs. They are the same base, so I know I can bring them together, and my variable's inside. So let's see if we can actually bring it all together and make it into one. So I'm going to start off by subtracting log from both sides. So this is going to become a log base 3 of our 4x squared minus log base 3 of our 5/3 x plus 2 equals 1. Okay, so now I've got them on one side. Well, our property told us that with subtraction we can actually turn it into a division problem. So let's make this into one log. So now it's going to be log base 3, because they were the same base, of 4x squared all over 5/3 x plus 2 equals 1. Okay, so that's nice. Now I have it as one single log. And at this point, so that we can get the stuff out of the log, let's switch it into exponential form. So I know, again, that 3 to the first power is going to equal that stuff on the inside. So our 4x squared all over the 5/3 x plus 2. Okay. Well, 3 to the first is 3, and I want to get rid of that denominator, so let's multiply both sides by it. So now we're going to end up with 3 times our quantity of 5/3 x plus 2 is going to be equal to our 4x squared. 4x squared. Okay, so distributive property tells us that we end up with 5x plus 6 equals 4x squared. Awesome. Hey, now it's a quadratic, right? So let's get it all on one side. So we're going to see that 0 equals 4x squared minus 5x minus 6. And now we can see if this is factorable or if we can plug it in the quadratic equation. Well, this is factorable, and for the sake of not having a whole lot of room left, trust me that it's factorable. If you have issues with factoring, go back and look at one of my other videos on how to factor this. We see that our AC is negative 24, and we can multiply to negative 24 and add a negative 5 with a negative 8 and a positive 3. When we factor left and right sides of that equation, we're going to see that this turns into 0 equals, our two factors will be 4x plus 3 times x minus 2. Okay, so I skipped some of the in-between steps of how to factor that, but you can go back and double check. 4x times x is 4x squared, 4x times negative 2 is negative 8, plus 3 gives me negative 5x, minus 6. So that's the correct factors. Now that zero product property rule tells us that x is going to equal, for this first product, it would be negative 3/4, or we would see that x equals 2. So those are our two solutions. Let's see if they both work. So you have to go take these and you gotta go back and plug them into the original equations for your x. Okay, we can't take a log of a negative number. So 4 times and then negative 3/4 squared makes it into a positive number. So we're good to go there. Okay, then Negative 3/4 times 3/5 is negative 15/12, which is less than 2. So this will turn into a positive number. We're good to go. Okay, then we're going to check the second one. There's 2 work in both of these cases. So 2 into there, 2 into there. Yep, that's going to be a positive number. We're in good shape. And that one, yep, gives us a positive number. So both of our answers will check out. Those are our 2 solutions. Hopefully that helps you out with some of your exponential and logarithmic questions. Thank you for watching Freeburg's Free Advice. Have a wonderful night.